This is question 26 on chemistry from section 2 of the 2020 BMAT. So we're given this equation that details the reaction for the synthesis of this fertilizer compound, this diammonium hydrogen phosphate. We're told some molecular masses, and we're told that 3.4 grams of ammonia reacts with excess phosphoric acid and gives the fertilizer with an 80% yield. Therefore, based on that, what mass of the fertilizer was produced in kilograms to three significant figures? So where should we start? Well, what do we need to work out from this mass of ammonia in order to complete this calculation? So we need to go via the numbers of moles of ammonia in order to work out the numbers of moles of fertilizer that we're producing. So how do we work this out? From the mass. So the number of moles is the mass of the substance divided by the relative molecular mass of the substance. We're given both of these, so that's okay. But what do we need to do first? So the mass is in kilograms, and the relative molecular mass is in grams per mole. So why don't we change everything to grams for now to make it easier? So we have 3.4 kilograms times 1,000 is 3,400 grams, divided by 17.0 grams per mole. Then what is this? Well, 34 divided by 17 would be 2. So 3,400 divided by 17 would be 200. And that gives us the number of moles of ammonia that we started with. So what's next to do? So we have the number of moles of ammonia, and therefore from what we're told, we should be able to work out the number of moles of fertilizer that produces. Now there are two things to consider here, and what are they? So we know there's an 80% yield, firstly, so we're not getting out as much we'd theoretically get from this much ammonia, but also there's the stoichiometric ratios of ammonia to the fertilizer. So we can see we started with twice as much ammonia as we form fertilizer. So these are our two things that we need to consider. So how do we incorporate these in our calculation? Well, firstly, to deal with this 80% yield, we need to multiply this value by 0.8. And we also need to divide by 2 to take into account these stoichiometric ratios. So 0.8 times the number of moles of ammonia divided by 2 is the same as 0.4 times the number of moles. What's 0.4 times 200? Well, that's 2/5. 1/5 would be 40, so 2/5 would be 80. So that's our number of moles of fertilizer that we're making. So we've got one more conversion to make, and that's the moles of fertilizer into the mass of fertilizer, which is what we're asked for. Now, how do we work this out? Well, by rearranging this equation here, we know that mass is the number of moles times the relative molecular mass. So we have both of these. The number of moles is 80, and the relative molecular mass of this fertilizer is 132. So how do we go about 80 times 132? Well, everyone has their own way of doing long multiplication. I personally prefer to split it up into sensible chunks. So this could be the same as 10 times 132 times 8. So we split up the 80 into 10 and 8, like so. And if we're timing something by 8, that's the same as doubling it again, then doubling it again. So let's do that bit by bit. Firstly, if we double 132 once, that takes us to 264. And then we only need to multiply by 4 rather than 8. If we double it again, that takes us to 528. Then we just need to double it one more time, which takes us to 1,056. So we finally multiply that by 10 to get 10,560 grams of fertilizer. So is this our final answer? No, because we're told two things. It needs to be in kilograms and to three significant figures. And so quickly, how can we do this? We divide by 1,000, to get 10.56 kilograms, and we round that up to 3 significant figures to get 10.6. So this is our final answer. We've taken everything we need to into account, and so we can be confident that the answer to this question is B.